Candles are scattered around, representing pieces of matter moving around in the nebula. Gravity causes the pieces of matter to clump together and form a star. The candles in the center represent the core of the star, and the candles on the outside represent the shell of the star. The outer candles are lit and they are pushing gravity inward. Nuclear fusion begins at the center of the star, which is pushing energy outward. The candles in the center have been blown out because the core has no more hydrogen to fuse. Gravity and the energy of hydrogen are no longer balanced. The size of the core must decrease. The candles in the center of the star move closer together. The candles along the shell of the star are still burning because they are pushing gravity inward. Because the core got smaller, it became hotter and denser. Helium begins fusing in the core of the star so the candles light and enlarge. The outer shell of the star enlarges so the candles move outward. There is no more helium left in the core of the star. Fusion must stop. The candles burn out and move closer together to represent the core getting smaller. The outer shell is still pushing gravity inward toward the core. Because the core became smaller, it is now hot enough to begin fusing again. The stars in the core light up and the outer shell becomes bigger. This process repeats until the core of the star is made of iron. When there is no fuel left for fusion in the core, the candles burn out and move closer together. The iron-filled core takes the energy from the outer shell of the star. The shell stops generating energy and moves inward toward the core. The star is now ready to collapse. The core of the star becomes extremely hot and pushes the star's shell away. The core shrinks one last time and the star explodes into a supernova explosion. A supernova explosion is larger than a nova explosion. The core will now collapse in on itself. If the core survives, and its remaining mass is between 1.5 to 3 times the mass of the Sun, it will collapse into a small, dense neutron star. If the star's retaining mass is greater than 3 times the mass of the Sun, the star contracts tremendously and becomes a black hole.